Great. And then we will start with, and let's just quickly get to it. Session 6 today. So basically looking at, again, a mix between study units 6 and 7. And then on Sunday, we will continue with study unit 8, which is again, what is it? Confidence intervals, I think. So today we will just continue with the continuous distributions, and that's normally normal distribution that we will focus on. And again, from previous assignments, and please, if you, I think I have shared some of those pre-COVID exams. If there's any of those that we need to focus on or work through as well before you write the exam, please let me know, and I will just put that into presentation as well, and we can work through it. Okay, so here we have a question that, so when we start looking at study unit 7, we basically need to start looking at the Z value that we will have. Now, instead of just looking at the standard deviation, we will have the sample component as well. And then what they do ask a lot of time is sometimes for you just to work out the standard error. And also just be careful in these instances, because sometimes there will be an answer for you if you work out the whole Z as well. So just be very careful that you read the question so that once or twice nearly to see what they are looking for. So in this one, a random sample, so we get the sample size is drawn from a normal distributed population with a mean of that, standard deviation of that. Determine the standard error of the mean and choose the correct answer. Okay, so we only need to focus on the standard error of the mean. So that is the standard deviation, which was 50. Divided by the sample size, or the square root of the sample size. So 50 divided by the square root of 120. And that gives us 4.56. Okay, which is option B. Okay, so this one, again, just be very careful that you don't start and work out everything. At least here, they didn't give you an X value, so that you couldn't really go all the way. But they did give the mean. So yeah, just be very careful that when you get a question like this, that just read it nearly 2 or 3 times and make sure what they are asking. Okay, so needed to work out standard error. Standard error is basically that component that you divide within the standard or the formula to work out the Z. Okay, so now we nearly look at the same information, But now they're taking it a step further. So now consider the normal distribution with a mean of 190 and a standard deviation of 120. A sample of size 50 is drawn from the population. What's the probability that the sample mean is between 150 and 190? Okay, so what they basically want us to work out is if we first look at the mean, so they say with a mean of 190 and a standard. Okay, so let's assume the mean is 190 there. Okay, that's a weird one, so let's redo it. 190 is going to be there. And somewhere here, going to be 150. So that's if we look at the mean, but we want to actually know what the Z values is. So we want to know the Z, and that will be 0, and what that Z is. Okay, so that is what we will need to work out. Okay, so let's consider we've got the mean. So the first one, and why I automatically set 0 is if you look at this formula, so if we have the mean as 190 and we have the x as 190, 190 minus 190 will give you 0, so we don't even worry about what's below. So it is going to be z, the one is going to be 0. Okay, so, but we also need to work out what the z is going to be 150. It is quite interesting that 90 that we used there, but let's see. The sample was size 50. Okay, so 150 minus 190 is minus 40. And then 120 divided by square root of 50. That is 16.97. So I get it as minus 2,36. Okay, so that is minus 2,36. Okay, so before we go into answers, it's all lying on the left-hand side. If that is 0,5, yeah, it will be 0.5 minus something. So we definitely going to be less than 0.5. So if I look at answers, might be, not. Okay, so at least we've got a few ones that we have eliminated. So let's go to the Z table. So let's quickly open that up. We have a negative Z table of minus 2,36. minus 2,36. So let's minus 2,3, 2,36. Okay, 0, let's just make that bigger. 0,0091, 0,0091, but that small area is 0,0091. So the area I'm looking for is then 0,5 minus 0,0091, which is equal to 0,4901, which is option C. Okay, so here's also one where if they have asked you what is the probability that the sample is bigger than 150, bigger or equal, then it would have been that whole area. Then it would have been option D. So that is, if it's, sorry, let me just write it in. If we said bigger than 150, that would have been your option. If it was smaller than 150, it would have been option A. So again, maybe they might, for some, ask you to work out between 150, 190. For others, they might ask you to work out less than 150, and then a third option might be if you need to work out bigger than 150. Okay, so again, in the option sets, there are nearly all of those three covered. They might even give a weird one, as to say, what is the probability that the sample is bigger than 190? So then you would have gone bigger than that. And then, so bigger or equal to 190 will actually give you option E. So once again, just all the different scenarios that can pan out with a question like this. Don't know where E comes from. I'm not even going to going to try and see how that fits into the picture. Okay, so you can now see again how, so what they also love to do is you won't really get a question to work out the standard error and this one for the mean, and then another question to work out, and this might not be proportion yet, so but when we get to it, proportion and the standard error around the proportion. So because that already then is four questions. So again, if we look at, you've got 11 chapters, most of them about 2 questions, then some of the others 3 to get to the 25 questions. So it's more likely that you will get one that you need to work out standard error and one where you need to work out the probability. So you need to know both, but you probably will not get 4 questions on study unit 7. So that's why, again, now we've including the standard error of a proportion, just that you can again see what that formula is. And that one is always the one that I nearly forget what it is. I think it's that, because it's normally something like this. And this time we again only need to work out this the standard error component. So they need to tell us something about the proportion. And luckily I can see here some numbers that they don't give it in words. I hate it when they do it in words because you don't normally pick it up. So most of the schools reported a decline in the number of absences following education department's learner transport program and school nutrition program in a sample of 90. So at least we also get the sample. 72 schools reported a decline. Okay, so we can then get the 72 divided by 90, and hopefully it's a nice fraction and not something that goes continuous fraction. Okay, so 0.8 is a nice fraction to work with. So we know then well, 1 is 0.8. 1 minus 0.8 will be 0.2. And the square root must be across everything. So in small errors like that can also give you different answers. So just be very careful again about making those small types of errors. Okay, so 0.8 times 0.2 divided by 90, and the square root of that gives me 0.042. Okay, 0.042. Okay, cool. So there it is. If I said 0.8 times 0.2 divided by 90, luckily there's not an answer for me, because that would have been 0.002. So if I then take just that square root, it is 0.042. Okay, so again, with that is basically 1 minus pi, or I don't know how they got to the others. Okay, so that is, sorry, where we needed to work out the standard error of a proportion. So nearly as we've seen with flow, and again, that will be how it is in your exam as well. You don't need to worry that now you get a standard error of proportion, and then the next question is regression, and when it comes back, it is as set up that your questions follow how your study guide is. So we go into the next one where now it's a bit different. We can still look at the information, but they want something different for us to work out. So here they say, consider the population proportion of 0.66 and the sample proportion of 0.75, given a sample size, and then calculate the t-stat. So here all that we needed to do was to work out the t-stat. Okay, so we needed to work out the z, not the probability or anything, only the z. So let's quickly again consider population proportion and sample. So I'm sure that is the correct formula. Again, I just want to quickly make sure. And yeah, I will also, in the next week, I'll send you a formula page where I have made some notes on it as well. And let me just quickly see, is this now right formula? I think it is, but I just want to minus. Cool. Okay. Great. Okay, so we have that. So let's quickly see, consider the population proportion. So we've got the population proportion. We've got the sample proportion. And then we divide. So the first thing that I looked at while we're now jotting this down is I was looking at the answers to see if everything is positive, because at the top it will be positive. So I was like, okay, if there was any negative numbers, then I could have cancelled it out, but nothing. So unfortunately, nothing that by just looking at it I can cancel out. So 0.75 minus 0.66 is equal to 0.09 at the top. Then below 0.66 times 0.34 divided by 90, and if I take the square root of that, is 0.04993. So if we get then z for that, it will be equal to 1,080. Why don't I get it? So let me quickly just check again if I've done it right. 0.66 times 0.34 divided by 99. So there I made a mistake. How easily one can do that. Is that the only mistake? Yep, 1,89. Sure, luckily there wasn't the option of 1,80, 1,89, which is option 1. Sure, how easily it was to make that mistake. And luckily there wasn't the answer. But that is, so if one of the options was negative, one could automatically cancel that out. If you also then see that it is negative, then it is also easy to pick up if there's only one or two answers that is negative. Okay, was there a hand or happiness to continue? And so I just on this, so even though they didn't ask us now to work out the probability, so if they ask us to work out the probability of z bigger than 1,89, let's say bigger or equal to 1, it would be that component. So let's go to the z table. We know that if I'm looking for that component, I can also use the negative. So minus 1,89 minus 1,89, there is a 0,0294. So 0,0294. And if I needed to get the area below, so z smaller than 1,89, I could also go to the positive table because that covers everything I'm looking for. 1,89 is 0,9706. 0,9706. And if you want to check those two need to add up to 1, which it does. So just if they were asking you to work out the z, that is how you would have done it. Sorry, not the z, the probability given that z. Okay, so that was nearly the 4 types of questions that will happen in study unit 7. So it is the standard error of a mean, or that you need to work out the probability with a mean, but to get to the probability, you also need to work out the z. Then it is standard error of a proportion, and then where you need to work out the z with a proportion, it could have also been that you needed to work out the probability of a proportion. So that's nearly the typical questions out of study unit 7. But obviously there is like 1 or 2 different types of questions. So let's just look at what other questions can come out of it. So again, you can see the same nearly information that we get in this one. So previous studies have shown that 71% of schools in the Sekuni district municipality have reported a decline. Suppose a sample of 99 schools is drawn at random. What is the probability that at least 80% of the schools have reported a decline in learner absences? Okay, so let's quickly. Previous studies show that 71. Okay, so we nearly want to work out the z at least. Shoo, now I need to. Do we have in that? I usually have the at least in there, but let's think at least is maximum. So at least okay, so at least means minimum and more. So what's the probability that at least 80% of the schools have reported? So if I draw it on a diagram like this, I would have said at least 80, so 80 or more. So that means if I would have drawn it on my diagram, and again, just nearly how I would have worked it out if I didn't have that table that you guys have access to, and I will copy that back in. So I'm basically looking for that area. So it should be bigger or equal to 80%. So 0.8 minus 0.71 divided by, that was the previous study, so that is what my population will be. Okay, 1 minus that is 0.29, and that divided by 99 again. Okay, so Z bigger or equal to 0.09. Wasn't that okay, the same? But the bottom one will be different, 0.71 times 0.29 divided by 99, and the square root of that. Sure, very close. 4, 5, 6. So it's Z bigger or equal to 1.97. So I'm basically looking for that area where it is bigger than 1.97. Okay, so now we actually need to use the table. Because they've given us the population proportion. Okay, so if they don't give us the population proportion, then we use the sample one. But because we get the population proportion as known, we use that population proportion. Okay, so most of the time we will actually use the population proportion because we know what the population proportion is, but they might, now that you mention it, they might, with this, where you need to work out standard error, but then again, you will only work out that bottom part, so then it doesn't matter if I tell you the sample, or so in this instance, we actually worked out not the population standard error, we worked out the sample standard error. So most of the time you will actually use the population proportion. Okay. I hope that makes sense. So if we have it, we use it. And that is most of the time. It might be when we need to work out So if we have gotten a Z and we need to work out what the one is, then we need to decide. I will check if I have something like that, where we are using the sample one. So let me go through a few questions and things, and let me see if I can't find something where we don't use the population proportion one. Okay, so I will check for us to look at that. Okay, 1,97. So I will go to negative 1,97. Let me just check. So 0,0244, 0244. Okay. So, but yeah, I will check for us if I can get us one that we use the sample proportion, because I think that will also be good just to see the differences. Okay, so let's look at another one. So this one, you could see what we now did was basically the same as I now just went a step further. So here is again what I mentioned last time. So where they give us that. So at least in this one, they also mentioned what the others are. So consider normal distribution random X with a mean of 150 and a standard deviation of 35. What is the probability? This is nearly taking us back to study unit 6. So consider normal random variable X with a mean of 150, standard deviation of 35. So they could have just given it to us in this format. So also be very careful that, so they're not done with 35 to the power of 2, but that could have also been 1, 2, 2, 5, so that you need to know that you need to take the square of that to get the 35. Okay, so here they nicely set 35 to the power of 2, but they could have just set, consider normal random variable, and then from there they could have just set X normally distributed norm, or X distributed normal, mean 150, and that is normally your variance. So your variance is 1, 2 to 5. And then from there you needed to know, okay, that is actually 150, and my standard deviation is 35. Okay, so again, I think I mentioned it last time, so this is how they could have just asked the question. And when they say the probability that X is smaller than 170, so let's look. X smaller or equal to 170 minus that. So that is 20. 20 divided by 35. Okay. So that is 0.57. 5714. Okay, so just look at that answer. So if we worked out the Z, there is an answer for you. Okay, but we want to work out what is the probability. So we need to go again to our Z table. That is Z equal to 0. That is Z equal to 0.5714. And let's just, it's smaller than that. So it will be something that is bigger than 0.5. So it's not E, it's not that one. So any one of those three, and it will be scary if it is actually option B. But let's go and look at Z equal to 0.57. Z equal to 0.57, 5757. Let's just check. 0.7157. 0.7157. Okay, so that is option C. So we basically then worked out the Z. We got the Z as 0.5714. Just be careful that they don't catch you out with that one. Because again, trust me, in your exam, you are pressured. You see it, you say, ah, there it is, but not realizing that you need to work out the probability. But then if you go to the Z table, you will see that is the probability that you are looking for. And again, if you might need to work out the probability X bigger or equal to 170, then there is the answer for you as well. So it might again be that some of you guys on your question paper needs to work out the bigger than 170. Some of you need to work out the smaller than 170. Okay, so let's see if there's another question on this. Okay, so now it is very much linked to one that we did last time as well. So suppose that the number of sale units for a product of interest is normally distributed with a mean of 101 and a standard deviation of 8. To break even, at least X numbers of units must be sold. Suppose further that the probability of breaking even is 0.7. At least how many units must be sold to break even? Yo. Okay, so let's quickly So suppose further that the probability of breaking even is 70%. At least, okay, so let's just, that needs to be big or equal to. Okay, so we've got 101. We need to work out the units. We've got that as 8. And we have the Z where they say, suppose that the probability of breaking even is 70%. So we can go to the Z table. We need to look at where Z, the probability is 70. I don't like this, but so we will say it's between those two, so 0.5, 2. So let's go with 0.5 to 5. I don't like it when we need to go between the two numbers, but let's see if that will work. So multiply out by 8 so that we can just get rid of that fraction. So 8 times 0.525. So 4.2 equal to, and now we can just change it to equal because we're working out the formula is equal to x minus 101. So if I take that to that side, I get x equal to 105. Okay, interesting. That was only 1.5 points. So what did we miss? At least how many units must be sold to break even? Hmm. Okay, what is wrong in this calculation? That's right, standard deviation. To break even, at least X number of units must be sold. Suppose further that the probability of breaking even is 0.7. At least how many units must be sold to break even? Okay, I don't see why that is not fully correct. At least how many units must be sold to break even? So maybe here was the extra component in that wasn't changed for the answer. Can you guys see why, if there's something wrong in this? So, So we've worked it out. That is probability of breaking even. That was 0.525. See, I think here was a mistake in the question. So let's just check if what is this? 105 divided by 0.7. I see 120 is also not, so I think here was a mistake in that they changed the question but didn't change the answers. Did you guys get anything different for this question? Yeah, I also can't see why that is not the correct one and only got 1.5 out of 2. I think they changed something in the question and did not change the options. Okay, so again, if you guys find something like this in your exam, just write down the question and afterwards you tell me, John, question 13, I think there was a mistake. I will send it to the lecturer, so we have normally a check-in after the exam, so I will send to him if you find something like that. So just jot it down. It should not happen, but if it happens, you just let me know. And also don't, if I think that's also important for you guys, even if you feel there was a question or two that might have been incorrect in the exam, don't please just let me know. It might be that yes, you have read it wrong or something like that, but rather say go and check than not saying anything. So please, even if it was a mistake on your side, please let me know. It's rather we make 100% sure that there isn't any mistakes in the exam. So you could maybe think you made a silly mistake, but it could have been something wrong on the paper. So then please just let me know afterwards. You feel there is a mistake of one of the questions. Um, just say it. Don't worry. I'm gonna tell the lecturer that students, so don't, what I normally would tell him, students found this question, so just make 100% sure. So please, if there is anything like that, let me know. So this one, I'm looking at this, so I would have in the exam, because I don't know if it's right or wrong, I would have gone with 105. And I can't see in this why it shouldn't be full marks in any case. Okay, so that was nearly for study unit 7. So let's just quickly add this one. I think we did something similar last time, so um, let's quickly just do this as well. Okay, so that we just make 100% sure that these things also don't catch you out. So EQ score of high school learners is normally distributed. There's a mean of 80, standard deviation of 20. If there were 1997 learners with a score higher than 97, how many students took the EQ test? Okay, so I'm already looking at this or at these answers, and I'm like, so if I just draw it on the mean and not even a Z, the mean is in the middle. That's 80. 97 will be somewhere here. And then if I say there was 1997 learners higher than 97, that already tells me, should I look at this 97, so on this side, there will be 1997. So just by adding those two, I'm around 4,000 already. So that is not going to be one of my answers, and that probably is also not going to be one of my answers. So my answer will probably be that number times 6 or 7. If I just look at how we look at the 80 and where the 97 is. So let's work out what the Z will be. And that's why I always like to draw the sketch, just that, so we didn't even need to do any sum yet, and we could actually have, where this student 2 or 3 years ago, you could see probably guessed that, you could already see that, yeah, there's actually 2 questions. So if you would have guessed, rather guess between A, B, and C, and something that actually will not nearly be able to be done. So, okay, so we've got 97, we've got the 80, we divide by the standard deviation of 20. So 97 minus 80 is 17. 17 divided 20, that gives you 0.85. And you could see this was done where this student, so there was again different options. This one was very similar question, but here it was 91 and 80. So I just included this so that you guys can see. For this one, it was 91, so you can get a few different options, but we're looking for Z 0.85. We want to look at what that is. When we get that answer, we can work out the rest. So let's look Z bigger than 0.85. So I will go to the negative one, negative 85. Let's just check. 0.1977. 0.1977. So if, okay, that's scary to look at those numbers. So then to see how many students are in total. 1997 divided by 0.1977. So that is also very close. So many easy mistakes one can make with all these numbers that are so similar. Okay, let me just 1997 divided by 1.19. Sure. Okay, so 10101. Okay, so that is option B. In this instance, the question was a bit different. So again, I will share this with you that you can just see how it was also asked, but basically they kept the 80 the same, the standard deviation the same, but they made the learners number different, and the X number different. So yeah, so I will definitely, you guys can practice this as well, because now you can see that answer is in both, that one is in both, that one is in both. So you can see they don't really change all the answers. They change one or two with a change in some of the numbers in the question. So, and that is what I've seen a lot in the exams as well. It's not suddenly new questions. It is a lot of previous exam papers that they do change the numbers a lot. Okay, so let's just see if there is, no, the rest is what we will tackle next time. So next time we will look at confidence intervals. So remember, with confidence intervals that we will do, we will have 3 confidence intervals. So we will, for the next session, we will look at confidence intervals around the mean where the standard deviation is known. Then we will look at the confidence interval around the mean where standard deviation is unknown. So we will work with a Z and we will work with a T table around those two. And then we will look at the confidence interval around the proportions. And then the proportion, again, we will use the Z table. So that will be our session next time. So on Sunday, and then around that again, also just a few things, and I'm going to look for questions where this time around they don't talk about standard error, but they talk about the error around the mean or around the interval, so that we nearly look sometimes at this component that way might ask you a question on. Okay, so I will look for questions around that we nearly need to work out the error in the margin, and then there will be ones that we need to work out the confidence interval as well. So that will be in our next session on Sunday, that we will cover study unit 8. Then the week after we will cover study unit 9, 10, and 11, and then that last week and a half we will focus on everything again. Okay, that is it for tonight. It was a shorter session than than usual. But yeah, I don't want to, I want to break it up this